So we're going to talk about differentials now. And people make the differentials a lot more challenging than they need to be. Really, we just need to go to a graph and to understand what the differentials are here. So I'm going to draw, as opposed to going back, because it'd have to go back so far. I'm going to draw our approximation that we did with the square root of x. There we go. That's a little bit better. So this is my linear approximation again with square root of x, and we'll just again have this be the center of 1. And so I'm going to just draw some things here. So actually what I'm going to do here is, this is my a value here. And then I'm going to draw over here my x value. Went to another notebook by accident. And so I'm of course doing this purposely to get some distance here so we can draw here. So basically some fancy things here is that we call this distance right here, we call this delta x. So we call this the differential delta x, which is just equal to x minus a. So a differential just means the difference. Fancy name for difference. Well, we're going to label one more. The other one we're going to label here is this one, and this we're going to label delta y. And of course that differential, if I look in that, delta y is equal to my linear approximation minus my f of x. Oh, I'm sorry, I'm spaced out here. That's not what I want to actually label. Sorry about that. Mislabeled that. We already have this. This is what we called the error. What I'm going to do here now is I'm going to draw a dotted line here. And this here, remember, this point, this line is f at a. My differential is this distance right here. So my differential is simply, if I look at what this is f at x minus f at a. Now, ultimately, to make this long story, I'm doing a poor job explaining this actually right now. Make a long story short, is that we say this differential delta y is approximately equal to f prime at a delta x. Because what we're saying here is f prime times delta x would be f prime delta x would be this distance right here. F prime at a times delta x is the distance from the linear approximation all the way down to f at a. And again, yeah, we have this error here, but we're saying, well, hey, you know, they're essentially the same. Now, the real reason we're interested in this has something more to do with when we're solving differential equations. So it's the fact that we approximate these things and then we take a limit, and so we get exactly equals, and then we get a equation that we can solve that's called a differential equation. Because what you do is you would say, okay, well, I'm going to, for instance, what you would do is you would say, oh, well, wait, I could do delta y over delta x is equal to f prime at a, and then you can do a limit, and you get derivative equal to each other. All the things that you're going to be asked to do is actually find the differential, and these should be the easiest problems on the next exam. Let me show you, do a couple examples here. Find the differential delta y if f at x equals x squared plus the natural log of x and a equals 1. So my differential delta y is just f prime at a delta x. That's all you have to remember. And well, let's figure out what f prime at a is. So f prime at x is 2x plus 1 over x. So then f prime at 1 is equal to 2 times 1 plus 1 over 1, which is equal to 3. So delta y is simply 3 delta x. And then we're done. That is all there is to these problems. Let's look at another one to make sure you understand how straightforward these are. Find the differential delta y if f at x equals e to the x plus the sine of x. So I'm not going to give you a center at this point. We can still find the differential. Delta y is equal to f prime, and I know it's at a, but we'll just say, well, it's f prime at x, delta x. And so f prime at x would be e to the x plus cosine of x so my differential would be, make sure to put it in parentheses, e to the x plus cosine of x times delta x. And then if we wanted to know what is the differential at a equals 0, we would simply do delta y is equal to e to the 0 plus cosine of 0 delta x. So delta y would just be to delta x. That's all there is with differentials. So that's the only types of questions I'm going to be asking with differentials. So as I said, they should be pretty straightforward problems.